Welcome you all for our JAS Academy. This is the Academy of Mathematical Science. We are giving a coaching classes for CSIR NET, GATE and Karnataka State Eligibility Test for MSc Mathematics students, and we are also conducting coaching classes for graduate student for preparation of JAM exam. I am proud to say that this is only one institute in northern region of Karnataka giving a coaching classes in mathematical science. Okay, in this video I am going to solve one more question that appear in KSET 2018 real analysis, especially in sequence. Now let us see that question. Which one of the following sequence is bounded and of finite range but does not have limit point? Option A is sequence I power n, where I is square root of minus 1. Option B, minus 1 to the power n divided by n. In option C, 1 plus minus 1 to the power n divided by n. In option 4, it is a n square. Before going to solve exact this question, we see theory background this example. Okay. Now, you know sequence. Sequence is a function. Sequence is a function from set of natural number to real number, and the sequence is denoted by this notation or by this notation, where an is the nth term of that sequence, and a1, a2, an, etc. are terms of a sequence we call. Now all the set of all terms of a sequence is known as range of that sequence. Okay, similar to function, collection of all the images we called a range. If a range set is finite, we call finite range. If a range set is infinite, we call infinite range. Similarly, same terms of a different terms of a sequence we call a range. If that range set is finite, we call finite range. If that range set is infinite, we call infinite range. For example, I will consider one sequence an, where an is equal to minus 1 to the power n for all natural number n belongs to n. Now terms of this different terms of the sequence are, just put n equal to 1, this is minus 1, plus 1, minus 1, plus 1. Plus 1, minus 1, and so on. Okay. Now range of the sequence is just 1 and minus 1. This is the range of our sequence. Okay, collection of all the terms of that sequence. Set nothing but repeated terms we cannot return, different terms only, 1 and minus 1. Now this set is finite or not? Yes, this set is finite, therefore this is a finite range. If it is infinite, we call infinite range. Then what is the meaning of a sequence is bounded or not? Okay, if a range set is bounded, means it has a upper bound as well as a lower bound, bounded below and bounded above, then we call that set is bounded. Now you see this example, range is a finite set and it is bounded, therefore our sequence we call it as a bounded sequence. Whether it has a limit point or not. Okay, limit point nothing but that is a unique point. If there exists a unique limit, then we call a limit is exist, otherwise a limit does not exist. If it gives more than 2 limit point, they are finite, we call this sequence is oscillating finitely. If it includes infinite limit also, we call that sequence is oscillating infinitely, and etc. etc. With this background, once again we see that example. Okay, in this example sequence they given that sequence is bounded. Okay, bounded means it is it is bounded below as well as bounded above. How we check a sequence is bounded? Based on its range set. If range is bounded, then we call sequence is bounded. And finite range but does not have limit point. Okay, these are the keywords you please underline while reading the question. Next, take first option A. In the option A, okay, they given that sequence is iota power n. Okay, this is our sequence. Now I will write the range set. Okay, you put a value is equal to 1, put I is equal to 1, n is equal to 1, this is I, n is equal to 2, minus 1, n is equal to 3, minus I, and n is equal to 4, 1, and these values are continued. Therefore, range set as iota, minus 1, minus iota, and 1 are the terms. This is finite or not? Yes, range set is finite set. What are the limit point? Iota is also a limit point, minus 1 is also a limit point, minus iota is also a limit point, and 1 is also a limit point. Okay, but does not have unique limit, therefore limit does not exist. Limit does not exist. Okay, does not have limit point. This is oscillating finitely. Okay, and yes, this is what's good for our condition, therefore this is selected. Okay, in the KSET only one option is right answer, then suppose the first option is right, then go for the other question. But this is a theory, we check all the options. Then what about the option B? Okay, now I will write range set for option B directly. Range set of that one is given by minus 1, 1 by 2, minus 1 by 3, 1 by 4, and so on. This is an infinite set, not a finite set. Okay, if it is infinite, therefore this is not true. Option B is not a correct answer. Then what about option C? Okay, same, once again I will write range set of that option